Exam questions solution HSEB 2064 question of OA group A. Question of OA, prove that the points 4, 8, the point 0, 2, 3, 0 and 7, 6 are the vertices of parallelogram. Solution. In this question 1, 2, 3, 4 we are given 4 points and we have to prove that the given 4 points are the vertices of a parallelogram. To show the given 4 points, the vertices of a parallelogram, let the given points be A 4, 8, B 0, 2, C 3, 0 and D 7, 6. The given 4 points we suppose as A, B, C and D. Now to show ABCD is a parallelogram, we have to show the opposite sides of a parallelogram are equal. So when the opposite sides are equal, if the opposite sides are equal, then the 4 points will be the vertices of a parallelogram. So let's find out the length of AB. Then we'll find out length of BC, length of CD, length of AD. Then we'll get opposite sides equal. If the opposite sides are equal, that means AB is equal to CD and AD is equal to BC. Then the given 4 points will be the vertices of a parallelogram. So first let us find out the distance of AB, or we can say length of AB, by using the distance formula. We know the distance of AB is root x2 minus x1 whole square plus y2 minus y1 whole square. The point A is 4, 8. We have supposed x1, y1. The point B is given 0, 2. We can suppose x2, y2. Now according to distance formula, let's put the value of x1, y1 and x2, y2. x2 minus x1 means 0 minus 4 whole square as it is, plus y2 minus y1 means 2 minus 8. 0 minus 4 minus 4. 2 minus 8 minus 6 minus 4 whole square, we get minus plus 16. 6 square means 6 is a 36. 36 plus 16 we get root 52 units. So this is the distance of AB, we can say the length of AB. The length of AB is root 52. Therefore AB is equal to root 52 units. After finding the length of AB, now we'll find out the length of BC. Distance of BC, or we can say length of BC. Let's suppose x, y1 and x, y2. The point B is 0, 2. The point C is 3, 0. Now equal to distance formula, D is equal to root x2 minus x1 whole square plus y2 minus y1 whole square equals to x2 minus x1. x2 minus x1 means 3 minus 0 whole square plus y2 minus y1 means 0 minus 2 whole square is equal to 3 minus 0 we get 3, 0 minus 2 we get 2, 3 square means 9, 2 square means minus plus 4, 9 plus 4, 13. Therefore BC, that means the length of BC, or we can say distance between B and C, is equal to root 13 unit. Next we find the length of the third side CD. We have already found the length of AB first side and length of BC. Now we have find the length of CD. So again by using the distance formula, C and D, supposing x, y1 and x, y2, the point C is 3, 0 and D is 7, 6. Now according to distance formula, D is equal to root x2 minus x1 whole square plus y2 minus y1 whole square is equal to, now x2 minus x1 means 7 minus 3 whole square plus y2 minus y1 means 6 minus 0 whole square. 7 minus 3 is 4, 4 square, 6 minus 0 is 6 square, 6 square is 36, 4 square is 16, 16 plus 36 we get root 52 units. Therefore, the length of CD, or we can say distance between the 2 points C and D, is equal to root 52 units. We have found the length of AB, BC, CD. Now we have to find the length of the remaining side AD. Now length of the side AD, or we can say distance of AD, A and D, supposing x1, y1 and x2, y2. The point A is 4, 8 and the point D is given 7, 6. Now by using the distance formula, D is equal to root x2 minus x1 whole square plus y2 minus y1 whole square. The value of x2 minus x1 means 7 minus 4, x2 minus x1 means 7 minus 4 whole square plus y2 minus y1 means 6 minus 8 whole square. 7 minus 4 we get 3, 3 square plus 6 minus 8 we get minus 2 square, 3 is a 9 plus 2 is a 4, 9 plus 4 root 13. Therefore the distance of AD is equal to root 13 units. The length of AD is root 13 units. The length of AB and CD. The length of AB and the opposite side CD we have got root 52, and the length of AD and BC, again the two opposite sides, we have got root 13 unit. It shows that the given points are the vertices of a parallelogram. So when the opposite sides are equal, when the length of opposite sides of a quadrilateral are equal, then the 4 points are the points of a parallelogram. Hence it is proved. HSEB questions answers. HSEB 2064 question of 4B group A. Question of 4B, find the equation of the straight line making 9 and 15 as the x-intercept and y-intercept respectively. Find the equation of the straight line making 9 and 15 as the x-intercept and y-intercept respectively. Solution. In this question, we are find the equation of a straight line whose x-intercept is 9 and y-intercept is 15. Solution. Let x-intercept is equal to 9. X-intercept is given 9. So let's suppose x-intercept A equals to 9. Y-intercept is given 15. So let's suppose y-intercept B is equal to 15. Now we are find equation of a straight line. We know equation of a straight line. When x-intercept and y-intercept are given, then the equation of a straight line is x by a plus y by b is equal to 1, which is also known as equation of a straight line in the double intercept form. The value of a is given 9, the value of a is 9, and the value of b is given 15. So we get x by 9 plus y by 15 is equal to 1. Taking 9 and 15 LCM, taking the LCM of 9 and 15, we get 45. 9 5s are 45 and 15 3s are 45. So 9 5s are 45. So 5 into x, we get 5x plus 15 3s are 45. That means 3 into y, we get 3y. So by taking LCM of 15 and 9 and adding the two fractions, 5x plus 3y as it is, 45 into 1 45. Therefore 5x plus 3y is equal to 45, which is the required equation of the straight line. So when x-intercept is 9 and y-intercept is 15, then the equation of a straight line 5x plus 3y is equal to 45.